All right, today we're talking about global weather patterns and their impact on biomes. Now, to review from weather, what we have is just a circular map of the world here, identifying the three major wind zones in both the northern hemisphere and in the southern hemisphere. This is our equator right across here. I've got it highlighted with a little bit of red. Please remember that the trade winds are a band of winds that are directly against the equator, and they blow towards the equator, and they blow towards the west. They blow towards the equator because, as we've said, the equator is the hottest part of the planet, and that hot, wet, moist air rises quicker than anywhere else, so the cooler air out of the north and out of the south come rushing in. The band of winds above the trade winds in the northern hemisphere and below the trade winds in the southern hemisphere, they're the prevailing westerlies. Like the name, they blow out of the west to the east, and they blow away from the trade winds. From the southwest to the northeast in the northern hemisphere, and from the northwest to the southeast in the southern hemisphere. The way that our curriculum works, we're not going to do too much in the southern hemisphere. A lot of our science focus is going to be in the northern hemisphere. To cap it off, at the polar caps are the polar easterlies. This is cold air that's sinking out of the North Pole and out of the South Pole down towards the equator, and it is also moving to the west. Biomes don't really happen by chance either. If we think about the map of the world, and I've drawn a map here, I got North America, South America, I have Europe, Asia, Africa. This dark line across the bottom is the prime meridian. I've got the equator across here. I have the wind band areas drawn in, trade winds, prevailing westerlies, polar easterlies at the top, trade winds, and prevailing westerlies at the bottom. I didn't get my whole planet on the map. These two lines that are dotted are the areas where about the wind zone starts shifting. If we look, it is easy to identify places on the map where we have things like deserts. For example, we have the American Southwest over here, and that's a desert. We have the Sahara, the largest desert in the world, right here. We also have deserts right here in South America. The Atacama Desert happens to be the driest desert on the whole planet. It's on average, there are parts of the Atacama Desert that that scientists think haven't gotten any real appreciable rain in something like 1,000 years. It's crazy. We also have the Gobi Desert that is buffered by the Himalayan mountains, and that's a different type of desert. On the other end of the spectrum, the wettest and hottest environments, we have the rainforests. We have rainforests here, rainforests through Central America. We have rainforests through Western Africa and the Congo. And then we have India over to the west, that's rainforests. I want to point out a couple things. If you think about the type of biome that a desert is, one of the characteristics of a desert is that it's very arid. It's very dry. Not just the soil and not just the sand, but actually the air itself is really what makes it dry. Any moisture that's in the area automatically evaporates into the air because the humidity is so low and the air can hold so much water. The problem with that, though, is that when there is evaporation, like in the North American desert, it is blown out and towards the east immediately by the prevailing westerlies. It doesn't really have time to gather and condense and rain in the desert. That water that might have been there goes somewhere else. The same is true here in the Sahara. If you look at the Sahara Desert, what you have is two areas where the wind literally is separating all the moisture, either into Europe and across Western Asia, or down into Africa in the areas that we know already have rainforests. The opposite end of the spectrum is the rainforest. Look at where our rainforests are positioned around the globe. The largest rainforest is in South America through Brazil. It's the Amazon rainforest. It is right off the coast of the Atlantic Ocean. Well, the Atlantic Ocean is right off its coast, really. And the trade winds are taking all that moisture and funneling it onshore. You have the hottest, wettest part of the planet evaporating and pushing all that evaporation onshore. So this area, this band gets the most rain on the planet. Same is true here in places like Madagascar and through Eastern Africa. you have the warm waters of the Indian Ocean evaporating and pushing onshore into Africa. Whereas just a couple thousand miles north, that moisture never gets because the trade winds push it out of the area. This pattern appears the same way all across the globe. In areas where the trade winds push out, we have deserts. Down in Australia, which we don't have on our map, this same pattern is repeated in the Australian outback, where the moisture is pushed out by the global wind patterns. The other thing we have to consider on top of these wind patterns is we have to consider the ocean currents. This one, I just drew a quick picture of the globe. In the northern hemisphere, all currents run clockwise. That means, for example, the east coast of North America, where we live, gets a current that comes up out of the equator area and runs up the coast, then cools down and comes back down towards the equator in Africa. Which means that the north, or the east coast, not north coast, the east coast of the United States gets warm, hot, humid water, which means that there's more evaporation here, and we have a deciduous forest. We have plenty of water to support a tree environment. Now, if the same is true, that means here on the California coast, we have this clockwise rotation, meaning that water that comes out of California is a cooler water temperature because it's coming up out of the Bering Sea. We know colder water doesn't evaporate as fast. Well, you take that colder water that's not evaporating as fast, and you put this, and right about here is the line, you put these winds pushing all the moisture out, and it's really kind of no wonder that the American Southwest is dry. Same thing here. We have cooler water in this area by the Sahara Desert, but we have trade winds and prevailing westerlies pushing it out. So it's not really a wonder that the Sahara is dry. Now, in the southern hemisphere, what we have is we have the opposite. We have counterclockwise currents, which means that all this warm water right around the Atlantic is pushed onshore. There's hotter water here, and it's colder coming up the southern coast of Africa, and we really don't have many rainforests right along the southwestern coast, very similar to the southwestern coast of the United States. On the other end of the Americas, we have cooler water coming out of the Antarctics. We have a much drier climate here by the Atacama Desert because the water's colder, along with the global winds that are pushing the moisture out. These global weather patterns are really the cause for the different types of biomes we have.